Welcome to the project demonstration of dual axis solar tracker with dual mode. So here one mode is sensor based tracking system, another is real time clock timer based tracking system, and also we have one more feature of solar panel cleaning mechanism that will be achieved with the help of our SG90 servo motor. And here we are going to do the tracking with the help of spur gear mechanism. So here we have mounted the solar panel for the tracking system in this spur gear and warm gear mechanism for east to west tracking, as well as for north deviation purpose also we are added the spur gear mechanism at the bottom of this solar tracking system. So here to control this particular DC motors, two DC motors for the tracking purpose, we are making use of L293D motor driver, and that L293D motor driver interfaces to the PIC microcontroller, that is PIC 18F 16F877A. So there's a 40 pin microcontroller, this one is a 40 pin motherboard, and this is the L293D which can control the two DC motors in bidirectional way, and so that we can achieve the tracking system. And we interface the LDR sensors, the 4 LDR sensors, 2 for east to west and 2 for north deviation, interfaces to this PIC microcontroller at A0, A1, A2, A3, and A5 is for the voltage sensor which is used to measure the voltage from this solar panel. And C0 and C1 and C2, C3 is going to be the controlling of the DC motors as L293D, and LCD interface rate C4 to C7 and B4 to B7. D4 to D7, 8 pins for this LCD, and B0 to B7 is for our keypad. The keypad purpose is in order to enter the time or in order to change the time inside this RTC clock from this keypad. Okay, and next, so let us see the demonstration and the particular voltage measured from this voltage sensor displayed on the LCD screen. And there will be a limit switches for east and west. So these two are the limit switches, east and west. Okay, and this is a north for deviation limiter or north switch. And here we are going to use a rechargeable battery of 3 amps. So this is the 3 amps. So each one battery pack consists of 3 battery cells. So each battery of 4 volt 1 amp, and those are connected in series, so that 12 volts 1 amp, and these 3 battery packs connected in parallel, so that we will get the 12 volts 3 amps battery power, and which is a rechargeable battery. From this charging circuitry we are going to charge this battery. So here we can see this there is a T and S. So T nothing but transformer, S nothing but solar panel. So this is the solar panel output. So if we place this here, we can charge the battery from the solar power. And if you want to charge the battery from the 230 volts input, so regular power supply, so this is the T transformer. Okay, so from this transformer, so just place this at this shown section. Yeah, right, at the T point we are connected to the transformer. Okay, and now just provide the 230 volts input to our system, and there will be a green light indication on the chargers indicating the battery is getting charged, and it will take minimum of 8 hours. So keep it is in charging mode from this transformer, so at least 8 to 10 hours, then only the battery will get fully charged. And after that, just disconnect that, and while kit demonstration we can place the solar panel connection back. Okay, and next, so if you want to enter the sensor mode or real-time clock mode, we can see one slide switch is there, so S and T. So now it is in S mode, sensor mode, and upwards T mode, that is going to be the timer mode. So if you want to enter the time, so for example the CMOS battery got discharged, and if you replace the CMOS battery, then the timer is going to be the 0. So if you want to enter the time, so before switching on this kit, so while I want to switching on this, so before switching on this, we need to hold these 2 limit switches at a time. Okay, so just I'm holding the 2 limit switches now, and I'm switching on this. Hold it, you can see set time. Now you can release the switches. So now it is asked for the enter hours. So now it's the time is going to be 1, yeah, so nothing but 13 1 from the keypad, enter 13, right, and then after 50. Right, now time set done, and now after time set done, so the motors start rotated to place the solar panel in 0, nothing but east side. As we said that it's going to be the east and it's a west and it's a north deviation. So once it reaches the 0 position, right, so it start cleaning initially. Right, the cleaning was done, and then it will display the RTC mode now. So it will display that 30 nothing but from 6 to 1 afternoon 1, 7 hours is difference. So now the system is start rotating to the 7 steps. So once the 7 steps is completed, then it will wait for the RTC input for the next hour. It will change into the next. So once 7 steps completed, on the LCD it will display the timing continuously, and the voltage is going to be measuring from the torchlight on here. So when we place the lighting on the solar panel, so then we can see the voltage is going to be the generated, because we have connected the solar panel here, right. And if we place this in sensor mode, if you want to change it to the sensor mode, then off the system and change the switching mode to the S. So here is the S, we have changed that to the S mode, and again switch on the system. So in both modes the system has to go to the 0 position, and after that it will display the which mode we have selected. Right. So every time it will clean the solar panel, and we can see the mode is LDR sensor mode, and so when the sunlight is falling on the LDR sensors, right, stops rotation and start rotation. So in this manner we can control the solar panel tracking system with help of spur gear and worm gear mechanism, and along with cleaning with sensor mode and real time clock mode.